All right. Okay, today we're going to talk more about expressions. So what did we say an expression was, an algebraic expression was last class? It's an algebraic expression is a meaningful collection of, help me fill it out. What was it? Yes, numbers, variables, and operations. Okay, an algebraic equation, that's different. What is the difference between an expression and an equation? An equation is a statement of equality between two algebraic expressions, exactly. So we're going to look at the difference between these two. Oops, I didn't mean to take the whole thing. Okay, so let's look down at example 1, and let's start to identify which ones are expressions, which ones are equations, and which ones are neither. Yes? Yeah, it does. That is what defines it. If it doesn't have an equal sign, it wouldn't qualify as an equation. Yes, that is a great. Yeah, so it actually has to have an equal sign. That's actually what separates an expression from an equation. Okay? Yeah, so let's look at the first one, A. What do you guys think about this one? This is an expression, and B is also an expression. What do you think about C? Yes, why? What makes it an equation? Yep, it has variables. It's a collection of variables and operations and numbers, and it has an equal sign. Okay, what about this one here? This one is a little bit awkward. And actually, this one's a little bit tricky. I looked in the PowerPoint already. This one right here is neither. And the reason why it's neither is because you wouldn't have multiplication and subtraction next to each other like that. That wouldn't really make any sense. It's like, well, what are you doing there? Are you multiplying or are you subtracting? Here, we wouldn't really also need this dot for multiplication, but here we're going 5 times negative 2. This is a little bit redundant. If you just put the 5 without the dot, it would mean multiply. So here, this one would be, what would you say this is? This one is an expression. And then what about the last one here? Equation. And these last two equations are also called formulas. This is the formula for circumference of a circle, and here we have the circumference, for the area of a, does anybody know what this is area of? Triangle, exactly. Okay, so let's start to begin to write a few more expressions. We were practicing this on the first day as well. Write an expression for each, yes. So an equation wouldn't be an expression because the equal sign, basically just because the equal sign exists, makes it an equation. So without an equal sign, we call it an expression. And you can think about it almost like English language, okay? If I say C is equal to 2 pi r, that's actually a complete sentence because I have the word is or equal to. That's a verb. I'm not really a very good English teacher, but an expression is actually an incomplete sentence. So 3a minus 6b. Okay. It didn't take any action. So that it's not equal to something, then it would be an expression. And that's the same thing in English. When you have an expression, it might not be a complete sentence. Yes. Oh, you could we're going to get there. We're going to combine like terms. It would still be an expression until we put an equal sign in it. Yeah. Okay. Let's go ahead and move on to this next one. Write an expression for each. So the length of a rectangle is 4 meters more than the width. Write an expression just for the length. So if we call W the width, we want an expression just for the length. 4 meters more. How would you write that? Yeah, 4 plus W. Now, if I write L equals, then I'm technically turning it into an equation. That's okay too, but they just said an expression, so that's why I'm leaving the L out of it for now. Okay? But there's a relationship between the width and the length. That's very good. Okay, there are 28 coins of nickels and dimes. Let X be, and this is what we call right here defining the variable. Define the variable. Let X be the number of nickels. Write an expression for the number of dimes. So you think about it. You might even think about it like this. You have a bag of coins, and there are 28 in there. X of them, I don't know how many, because we're using a variable to represent the unknown. I don't know how many of them are nickels, but if X of them is nickels, how many are left that are dimes? So let's make up a number. Sometimes maybe it might be easier to make up a number for the nickels. If there were 10 nickels, how many dimes would there be? 18. What did you do to get that? Subtracted. So if you know that you start with 28 coins and you're taking away X of them because you don't know how many there are, that would be an expression for how many dimes there are left because we assigned X as nickels. Are you seeing that? Right? A certain portion of them are dimes, X, and so if you take away that X from the 28, that's going to leave you how many is left. So if you think about it even in terms of a number, sometimes that can help you think about what operation you did. Yeah? The next one. Janie has $92 before paying X dollars for a pair of boots. Write an expression for how much money she has left. 92 minus X, the same thing. 92 minus X. This is how many she spent on the pair of boots. So that's how much money she'll have left. In an election, there were 2,756 votes cast. Let X represent the number of votes of the winning candidate. Any thoughts about that one? Oh, write an expression. I didn't read the whole thing. Write an expression for the number of votes cast for the losing candidate. What do you guys think about that one? So if we maybe we act it out, we could draw a picture. Over here, X was the win. How much is left? How many votes were there total in this whole bin? 2,756 votes total. How many were in the lose side? Yeah, 2,000, sorry, I can't read numbers. 2,756 minus X would be for the loser, yeah? The same principle. These are almost the exact same problems, but a lot of times they get a little bit confusing in terms of the order, because with subtraction, does order matter? With subtraction, order matters, right? With addition, does order matter? No. And we call that commutative. The commutative property of addition means that you can add in any order, but you can't subtract in any order. It's like, the commute from your home here is the same in either direction. You had a question?